All right, so we are finishing up 3.7 quadratic quandaries with this section right here, and then going over the takeaways as well. And so what I wanted to share really quick with this is there's a couple different ways to do it, okay? One of the ways to do it is setting it equal to 0 and just pretending that this is an equation, not an inequality, finding your solutions, graphing it, and then figuring out which section, left, middle, right, are your solutions. That's where they live, right? So that's one way to do it. The other way to do it is actually graphing it. I will be requiring this way, so I need to see your work. So always use the graphing way to check your answer, but I will be showing you how to graph this. Okay, or sorry, how to solve this. So the very first thing that I do is I look at this equation and I say, oh, it's x squared plus 3x minus 10 is greater than or equal to 0, right? And I'm like, oh, okay, I know how to do this, okay? So the very first thing I do is I pretend, and I'm going to pull this over here. Okay, the very first thing that I'm going to do is I'm going to pretend that this says equal to. So it says x squared plus 3x minus 10 equals to 0. Ms. Johnson, can you just change it like that? I'm not really changing it. I'm just solving it by ignoring this for right now. At the very end, I will change it back. Okay. Okay, so what I'm going to do right now is I'm going to solve this. So which way would Miss Johnson solve this? How would Miss Johnson solve this? Yeah, I'd factor. So I'm thinking of what two numbers multiply to get to -10, but add to get to 3, right? And so you're thinking, oh, that's right, that's x plus 5, x minus 2. And so if you forget how to factor, no problem. Just go watch some of those old videos on how to factor, and it'll give you some pretty good reminders. Don't forget how to factor, because actually right now my integrated 3 class is getting back into factoring, right? So the factoring that we just learned, Ms. Johnson, yes, the factoring that you guys just learned. So then from here, you guys all remember, now we're going to use our zero product property. So what are our answers? Yeah, absolutely. Yeah, so someone says, Ms. Johnson, our answers are x is equal to -5 and 2. And that's very good, because what they did is they set each of these pieces equal to 0, x plus 5 equals to 0, x minus 2 equals to 0, and then they solved them. So our answers are x is equal to -5 and 2. So the first thing that I'm going to do, so like, let's just say I'd be done right now if we were in the earlier part of this chapter or in the last chapter, okay? But because we're solving an inequality, this is where the inequality starts happening, okay? So the very first thing that I'm going to do is I'm going to graph these numbers on a number line. So -5 and 2. Very good. So I see you guys participating in the chat. Thank you so much. That helps me know which way I'm going, if I'm going too fast, too slow, too whatever. Okay. So very good. Okay. So I graph my numbers, which it's going to show up in just a little bit right here, -5 and 2. And so if you can imagine, I have 3 sections, the left section, the middle section, or the right section. In about a second, I'm going to check which one of these sections work by plugging in a number in that section. Before I do that, I need to determine whether my circles are open or closed. Does anybody remember what I should be looking at to tell me whether these are opened or closed? What should I be looking at? What should I be looking at? Yes, very good. Someone says, Ms. Johnson, they are closed because of the equal to sign. Very good. So I'm going to point out what they're saying. So this equal to sign here, I'll put the equal to sign, means a closed circle, right? It also means that 2 is a solution. It means that 2 and -5 are solutions. So I'm going to color this in here, and I'm going to write this as my little note. Closed because greater than or equal to. So equal to is your clue there. Okay. So again, you're going to learn this slowly by slowly. So it's okay. So then how do I check? Oh, God. Is it, how do I check if it's the middle section, the right section, or the left section? What would I do? What should I do? How would I check if the middle, right, or left section is it? What would I do? Yeah, good job. Okay, so all you do is you pick a number. And so my favorite number, does anybody know my favorite number to plug in? All the time. What's my favorite? Yeah, my favoriteest number to plug in is 0. Why, Miss Johnson? Because it's easy to plug in. Okay, so I'm going to graph the number 0. It's probably over here-ish, right? So this number 0, I'm going to take my favorite number 0 and I'm going to plug it into here to see if it's a true statement. Okay, so I'm going to say 0 squared plus 3 times 0 minus 10. Is that greater than or equal to 0? So that's 0 plus 0 minus 10. That's negative 10. Is negative 10 greater than or equal to 0? Is negative 10 greater than or equal to 0? Everyone says no. Yeah, this is not true. So this is false. So this is not a solution area. So Miss Johnson, but you didn't check all the numbers in this area. You're right. But by checking one, that tells me the status of everybody in between -5 and 2. Does that make sense? So most likely, because it's not in the middle, it's going to be on the outside. Okay. Both outsides, Miss Johnson, most likely. But your practice is to check both sides. Okay. So right now, I'm going to pause the video. I need you to plug in a number on the right side and a number on the left side to see if you got it right. So right now, you're going to check a number on the right, a number on the left, to see if Miss Johnson's right, that the solution is both out here and out here. Okay, go ahead and do that. Okay, so you should have checked the right side and the left side, and you can use any number that's to the right of 2 to check the right side. So you could have checked 2.1, right? But that's annoying to plug in. So I'm not going to use 2.1. Okay. I'll probably use like the number 5 because I could do all that math with 5. If you wanted to use 10, you can use 10 because you guys could do the math with 10, right? In fact, that's what I'll do. I'll use the number 10. So let me use this color here. So I'm going to use, oops, that's the same color. Let me use this number. So I'm going to use this number. I'm going to pretend that's the number 10. And I'm going to plug it in. So I got 10 squared plus 3 times 10 minus 10. Is that greater than or equal to 0? So I get 100 plus 30 minus 10. Let me let my computer catch up here. So I plugged it into here, right? And then I'm simplifying. And then I go like this: 100 plus 30 is 130 minus 10 is 120. So is 120 greater than or equal to 0? And you're like, yes, true, whatever you want to say, right? So the fact that this is true means that 10 is a solution, tells me all the numbers on the right side are solutions. So I just do a little squiggly line like that says this is a solution. Sometimes textbooks do this thing where they go like this and they make the line extra thick, but I want to make it super clear to you that this is a solution. That's why I squiggle it out. It's almost like I'm shading. Does that make sense? Okay. Then what I want to do, okay. And then what I want to do is I want to check the left side. Now you can use any number you want, any number to the left of -5. So if you wanted -4 no, sorry, negative 5.00000001. But again, that's really annoying to plug in. So I'm just going to try negative 10 because I already plugged in. I already plugged in 10, so I already have half of that. So negative 10 quantity squared, meaning parentheses. This is important. When you're plugging in, the negative 10 has to go into a parentheses like that. And then plus 3 times negative 10 minus 10, is that greater than or equal to 0? That's a question, right? So I'm going to solve. It's 100 plus negative 30 minus 10. Is that greater than or equal to 0? And so what is that? 40? No, that's 60. Yeah, that's just 60. So 60, is it greater than or equal to 0? And you're like, yes, this is true, right? And because it's true, it means I should shade it. So I'm going to shade this whole left side, showing this is where it goes. All of the numbers on this left side are solutions. So any questions? So this part here, I'm going to assume you guys understand. I know how to solve the quadratic, Ms. Johnson. Okay. The next part is do you know the difference between open and closed? Should this be a closed dot or an open dot? You should be okay with that because it has the equal to sign. Some of you call it the underline. Absolutely. Okay. The last part is, do you know how to check which sections are solutions? That's literally you just plugging in and saying yes or no. Okay. Yes or no. Okay. So looking at this, oh wait, before I move on. So when you look at these two, you should be able to tell a couple of the things that you already know about this graph. The very last thing that you're going to do is you're going to write out the solution. Okay. So writing out the solution is none other than you describing it. Now here, we described this one as it, because it's in between, you write x is less than 4, greater than negative 12, because it was in between. Because this is not in between and it's two pieces, I have to write it out as two pieces, right? So I'm going to write this out as two pieces. It doesn't matter which piece you write first. I usually work from left to right. So I'm going to say x is what then negative 5. X is less than negative 5. Less than. And I'm going to put the equal to sign because it's equal to. It could be equal to, right? And then I'm going to write or x is, and then put the 2. And what way is this? Is this less than or is this greater than? And yeah, this is greater than or equal to. So these are all the numbers that work. And this makes sense because we were checking the numbers to the right of or greater than 2. And we were checking the numbers to the left of or less than negative 5. So this is definitely an or situation. Okay. Definitely an or situation. And Ms. Johnson, what do you mean by or? Because it's split into two parts. It could be on this side or this side. Okay. Just so that we can remind you how to check your answer, I'm going to show you so that you guys can all see what this means. So you can actually graph x squared plus 3x minus 10. Oops, minus 10, not it's minus 10. Not times, minus. Okay, so here's that parabola, and you're trying to see when it's greater than or equal to 0. So I'm going to graph the second line as y equals to 0. Okay, you can actually graph inequalities in this. Oh, someone said, hey, Ms. Johnson, why isn't it and? It's not an and because I don't want the numbers that are less than negative 5 and greater than 2, because there are no numbers that are less than negative 5 and greater than 2. Really good question. It's an or because it's like this side or this side. Okay, you actually can graph like this whole thing to find all the solutions. I'm not going to show you that because There's a couple of things that I would have to show you. So, oh, where'd it go? Here it is. So I do want to show you this. So it's asking, when is the red function greater than the blue function? When is the red function greater than the blue function? Where do you see the red function above the blue function? And you should say, oh, Miss Johnson, it's all of this time. And I'm going to highlight using my little annotation. Hold on a second. It's all of this time here. Go with an orange so you guys can see. It's all of this section here, Miss Johnson. This red is above, and then it hits the line, and then I stop. This is below, this is less than, this is less than, this is less than. Oh, it's equal to, boom, right? And it's all the way up. Okay, so it's all of this time. How would you describe that? Well, yeah, above the blue line, exactly. So I'm looking for all the numbers that are left or less than -5 or equal to it, or greater than or equal to 2. You guys all see that? So that's what this symbol means. It's saying, hey, when is it above that line? So I took a long time to show you this so we can kind of move faster with these two ones. But this is generally how we're going to do it. We're going to pretend and solve that it's an equation. So it's equal to. We're going to get our solution points, and then we're going to figure out which sections work. Now, sometimes it's only one section. Sometimes it's 2 sections. And I'll be honest, it could even be all the sections or none of the sections. Okay. So that's why we check every single section. Okay. So I'm going to have you guys try this on your own right now. Now that you understand how to do it from beginning to end, I'm going to have you try this one on your own. Then I'm going to send you to groups, and then we're going to come back and see if you guys got it. Just number 9. Okay. So check back in a second. So you had a chance to do this problem, and now we're going to make sure that you guys understand how to do it right. So I'm going to start this problem over. And the very first thing again is I'm going to write this down. So 2x squared minus 5x is equal to 12. Now I changed that less than to an equal to because, oh yeah, you can always do your work on paper. I prefer that. And you can always take your pictures and put them up on there, and that's fine. So, or you can even put it on OneNote. That's fine. So here, the very first thing I do is I set it equal to 0. And then once I set it, I changed the less than to equals. And then the next thing I do is I set it equal to 0. So I'm going to subtract 12 from both sides. If that feels weird to you, no problem. You just want one of the sides equal to 0. If one of the sides doesn't equal to 0, you manipulate the equation so that it is equal to 0. So then I get 2x squared minus 5x minus 12 equals to 0, right? And then so now I'm going to solve this thing. And so this is when Miss Johnson will use x in box, right? So here's x. So 2 times -12 is -24x squared. And then this is -5x. And then I use a box, right? But first, before I do that, I think what 2 numbers multiply to get to -24, sorry, but add to get to -5. So if you don't know that, you would write out your factors. 124, 2 times 12, 3 times 8, 4 times 6, and you're looking for a sum or difference of -5. Okay, I'm looking for a sum or a difference of -5. And so the only one that gives me that is 3 and 8. So I put 3x and 8x. And then I say, oh, okay, I think it has to be -8. And then I check. So 3x times -8x is -24x squared. Check. 3x minus 8x is -5x. Check. So then I fill in my box. First term, first box. If you need reminders of this, no problem. Go back to that video. Minus 12 here. And then these 2 numbers here, 3x and -8x, go here. So 3x, -8x. Okay. So then I start asking myself, hey, what's the greatest common factor between 2x squared and 3x? And you guys will say, oh, it's x. And then play who's missing. X times what gives me 2x squared? And you say 2x. And then I move over. X times what gives me 3x's? And you say plus 3. And then I say 2 times what gives me negative 8x? Negative 4. And oh, it's not catching up to me. Hold on. There it goes. So negative 4 times positive 3 is really negative 12. So then my answers are 2x plus 3, x minus 4 equals to 0. So this is the one that I suggest to like actually write it out. So 2x plus 3 equals to 0, x minus 4 equals to 0. So if you solved each of these, you would get x equals to negative 3 halves, which I saw some of you have, and 4 as my answers. So again, this is me being done solving a quadratic equation. Now I'm going to bring in the fact that it's a less than symbol by number 1, graphing it on a number line. So this is negative 3 halves. This is 4. So the first thing we have to do is determine what? What do we have to determine for this number line? What's one of the first things we need to do? What do we need to do right here, guys? Come on. What do we need to do? Yeah. Is it open or closed? You guys tell me. Is it open or closed? Very good. Thank you for participating. Very good. So yes, it's open. If you don't know why it's open, you should look up here. So this means closed. Why is this one open? What told you this is open? What told you this is open? Very good. Thank you for participating, y'all. Yes, it doesn't have an equal to sign. So whoever said that, that's some genius math skill there. So you're saying, Ms. Johnson, if it does have an equal to sign, we have a closed circle? Yes. So therefore, if it doesn't have an equal to sign, it doesn't become closed. Therefore, it's open. Just like that, Ms. Johnson? Yes. Don't color it in. That's what I'm saying. Very good. Okay. Then we have to pick which section. Is it left, middle, and or right? How do we do this? How do I determine which section I'm going to color? How do I determine which section I'm going to color? Yeah, right. So again, what's Ms. Johnson's favorite number to check? What's Mrs. Johnson's favorite number to check? Yeah, Ms. Johnson's favorite number to check is 0. 0 happens to be somewhere, I don't know. It doesn't have to be exact. Wait, why is this being weird? Oh, there, sorry. So there, that's where my 0 is, and I'm gonna check it. How do I check it? I just plug it in. So I'm gonna go 2 times 0 squared minus 5 times 0. Is that less than 12? Is 0 minus 0 less than 12? And you guys say yes or no? Yes, it is. So I'm gonna shade this. 0 is less than 12. Because 0 is less than 12, right? Because 0 is less than 12, then that means I could shade that in, right? If this was not true, then I wouldn't shade it in. And then I would check the numbers over here and over here really quick. I'm just going to check them. I'm not going to write anything down. I'm just going to check in my head. So 10 squared is 100. So that's 200 minus 50 is 150 is not less than 12. So that's not a solution area. That's this area, not solution, right? And then I check negative 10. So that's negative 10 squared is 100 times 2 is 200. 200 times, so this would negative 5 times negative 10 plus 50. So 250 is not, no, that's not it either. So my answer, now you tell me, is this one section or two sections? Yeah, it's one section. So then my answer looks like this: -3/2, x, and 4, and then these less than symbols. So -3/2, I put an x, I put a 4, and then I put these less than symbols. The way we read this in English is inside out. So x is less than 4 and greater than -3/2. If I was to check this, and I need you to check this on your own, on the graphing calculator, because I'm running out of time, on the graphing calculator, it would show you a parabola, and I wanted to know, when is the parabola less than 12? So it would be all this section in the middle here, from -3/2 to 4. Okay, so very good, very, very good. I'm going to switch over to the takeaways because I want to make sure that we get those in. Actually, yeah. We'll finish these off with the takeaways really quick. So you know how to solve a quadratic inequality, right? We just did a couple of them. Number one, you're solving it as a quadratic. You're putting those solutions on a number line, just like we did. Here, I'll show you. You're putting those solutions on a number line, and then you're verifying which section contains solutions. Okay, so you know how to do this. You're actually, I saw a lot of your work. It's pretty strong. So a function whose degree is 2 and where y is not always exactly equal to the function, these types of functions are usually called an inequality. Inequality symbols that include the symbols we know as less than, greater than, less than or equal to, or greater than or equal to. For example, this, right? So you know how to solve this. We reviewed how to do it graphically and algebraically. Okay, very good work.